Hello everyone, welcome to our channel Code with Sunny, and in this video we will be talking about the problem delete and earn. Its index is 740 and it is the medium problem of the LeetCode. Okay, so before moving on, let's discuss the concepts that is being required to solve this problem. So basically we are going to use dynamic programming to solve this problem efficiently. So if you are unaware about this term, so no need to worry about. You are going to have the lot of articles over the internet. Okay, and another concept is like hash table. You can use that also, but in this video I will focus mainly on this approach. Like, yeah, I will tell you how to solve this problem efficiently with the help of dynamic programming. And also we are going to have the sortings. You need to use a standard inbuilt sort in your respective languages, so to sort the array. So basically our main idea is to how to modify a problem statement to solve this problem with the help of DP concept. Okay, so let's begin with the problem. We'll be given an integer array nums and we want to maximize the number of points we get by performing the following operation any number of times. Okay, so there will be some sort of operations. Pick any number, nums of I, and delete it to earn nums of I points. Afterwards you must delete every element equal to nums of I minus 1 and nums of I plus 1. Okay, now so there are some of the key points you need to remember. You must delete every element equal to nums of I minus 1. That is the number you choose, let's say A, then you need to delete all the occurrences of the A minus 1 as well as A plus 1 in the array if it exists. Then if after doing that we are going to earn A amount of points, A is the number being chosen. What is the maximum number of points we can earn by applying the above operation some number of times? Okay, so we need to maximize the points that we are going to get. So I will deal all those examples. For now, let's look over the constraints. You can see the max value of the array is 2 into 10 raised to the power 4. So we can have a O of n time or O of n log n solution. So in this video, we will focus upon n log n solution along with the dynamic programming to find out the maximum number of points we can have. Okay, so let's begin to understand this problem first. So suppose we would be having some array A0, A1, A2, A3 and A4. For now, for an instance, we have 5 elements. Okay, so for every operation we will be choosing one element. Let's say we have chosen A3. Okay, so A3 has some value, so we will choose A3, and after choosing A3, whatever the elements that are present in the array with a value exactly equal to A3 minus 1 and A3 plus 1 will be deleted. So after deleting that, our points will be incremented by A3 plus A3 points we will earn, and we are going to repeat this operation till till array becomes empty or non-empty, like till we are not being able to do some operations. Okay, so let's take an example and understand how the things will work. So let's say I am going to take an example 2, 3, 4. So this is an array. So in one operation what you can choose is, let's say you have chosen the value called as 2. Let's say you have chosen the value 2. So your cost or your answer that you need to maximize will be exactly equal to 2 because you have chosen 2. So when you are chosen 2, you need to delete all the occurrences of A plus 1 as well as A minus 1. Okay, so also you need to delete the elements being chosen also. Okay, so 2 is deleted and you need to delete 2 plus 1 which is 3, and also you need to delete all the occurrences of 2 minus 1 which is 1. So in the original array, whenever you will see 3 and 1, it will be discarded because you have already chosen 2. So 3 is discarded and 1 is not present in the array, so we will leave it as it is. So the elements that is being left is only 4. So in the next operation my cost would become 2 plus 4 because I am going to choose 4. So my cost would become 6. This is the maximum number of points we can get. So when you choose 4, you will delete 4 as well as 4 minus 1 which is 3 as well as 4 plus 1 which is 5. So you need to delete 4, 3 as well as 5. 3 elements you need to delete. 4 is present in the array, so you will delete it. 3 is not present, 5 is not present, so it is okay. So now you can see array becomes an empty array. So your cost is 6, which is the maximum answer you can get. So you can see it is matching with 6. So let us understand how this will work. 2, 2, 3 times 3 and 4. Okay, 2, 2, 3 times 3 and what is that? 4. Okay, also one thing that you need to take care for that is, yeah, in this problem, like in this example, I have chosen 2 first. Like I have chosen, I will start choosing with the value 2. You can choose some other element also. Let's say you have chosen 3. So for an instance, let's say I am choosing 3, so cost would be 3. And yeah, the array is actually 2, 3, 4, right? So 3 is discarded, and the 3 minus 1 as well as 3 plus 1 will be discarded. Like all the occurrences of 3 minus 1 and 3 plus 1 will be discarded. So 4 will be discarded, 2 will be discarded. You can see cost will remain 3, and we have an empty array. So you can see cost is 3, which is not the maximum because we are getting 6 as the maximum answer. Okay, so let's say we have 2, 3, 4 again, and for now we are going to choose 4. So if we'll choose 4, then you can see, yeah, cost would be 4, and 4 will be discarded, 3 will be discarded, again 2 is left, so 4 plus 2 will be 6. So 6 is the maximum answer. So each time you have a lot of choices to choose the number and delete the occurrences of the chosen number minus 1, chosen number as well as chosen number plus 1. Okay, note that whenever you choose a number, let's say we have chosen 2, then it's only exactly one occurrence will be deleted, and all the occurrences of the neighboring elements, that is a minus 1 and a plus 1, where a is the number being chosen, will be deleted. Okay, so let us focus on the other example which I have taken over here. So this will explain, this will help us to learn a lot. So you have a choice. You will choose 2, you will choose 3, you will choose 4, any of the numbers. So which number you will choose? So in the brute force solution, you will think that I have to consider all possible cases and you need to maximize your answer, right? So for now, let's understand by choosing 2 first. Okay, so we will say I will choose 2. So cost will be 2. So when we choose 2, this will be discarded and all the 3's will be discarded and all the 1's will be discarded because 2 minus 1 is 1. So you can see cost is 2. So next step, I have the possibility of choosing 2 as well as possibility of choosing 4. You can see we can choose both of them in separate operations, because choosing 2, when we will choose 2, again 3 and 1 is discarded. When we choose 4, 3 and 5 will be discarded. So we can choose both. So 2 plus 2 plus 4. So this will be the cost, which is actually 8. So when you will start with choosing 2, you can get the value 8. But can we have the maximum answer more than this? Like, can we maximize our answer? So yeah, we can still maximize the answer. So how we are going to do that? Okay, so let's consider by starting with 4. So my cost would be 4 plus we have some other one. So when we are choosing 4, all the 3's will be discarded as well as this 4 will be discarded. And again you can have these two, so you can choose in separate operations. So you will have the cost as 8. So when you will start with 2, you will get 8. When you start with 4, you will get 8. So what about when we start with 3? So when we start with 3, let's say we have chosen this 3. So this will be discarded and all the 3 minus 1 is 2 and 3 plus 1 is 4 will be discarded. So cost will be 3 for this choosing this one, and we have all the remaining 3's we can choose in separate operations, so which is 9. This is the maximum answer we can get. So how to find out efficiently that which number is going to be chosen and which number is not going to be chosen? So we will use the idea of dynamic programming. Okay, so let us use dynamic programming to solve this problem. Now you can see, since whenever we will choose some element, that it totally depends upon whether the previous element is being taken or not. So what I am going to do is, in the very first idea is sort the array. Sort the array. Okay, not calling it as sorting the, yeah, you can use that. So what is the main idea is, we will keep the pairs let me write down, keep the pairs element comma frequency of that element in a sorted form according to the element value. So whenever you consider this array, you will be having 2 and its frequency is 2, 3 its frequency is 3, 4 its frequency 1. So we have the pairs in the sorted form like this one, and the pairs is sorted according to the element, right? So let us move on to the next page and understand how the things will work. So we have an array 2 comma 2, we have a 3 comma 3, and we have a 4 comma 1. Okay, so the actual array was actually 2 2, 3 3 3 and 4. Okay, so when we take the element comma its frequency and sort it, we will get this one. Now this will help us to understand how we will maximize the number of points. Okay, so consider the dp state as dp of I as maximum number of points we can get by choosing not saying as choosing, by considering first I pairs. That is, you will consider if I is 1, only this pair is considered. If I is 2, only this pair is considered. If I is 3, all the 3 pairs will be considered. Okay, so just tell me one thing, that what is the value of dp of 1? So dp of 1 will be, if you consider only this pair, so there are 2 elements and each of the elements can be chosen in a separate operation. So your answer will be 2 into 2, which is 4, right? Now comes the value of dp of 2. Now here is the tricky case. So for every element in general, we can say dp of I will be, what we can say, either choose this element, choose the current element, or don't choose this element. There are two possible ways: choose the current element or don't choose the current element. Okay, so it totally depends upon the difference between the current value element and the previous value element. So what we are going to do is we are going to check it out a condition, that is if the current element, like let's say element of I minus element of I minus 1 is exactly equal to 1. You can see 3 minus 2 is exactly equal to 1 and 4 minus 3 is exactly equal to 1. So this condition will become true. Okay, so if this condition holds, so you will write the answer as dp of I as max of two elements. We are going to consider two things: either choose this element, choose, don't choose. That is, we are going to choose this pair, otherwise we are not going to choose this pair. What about if we will choose this pair? Okay, and the difference is exactly 1. You can see difference is exactly 1 and we will choose this pair. So when you will choose this pair, obviously this pair will not be chosen, because when you will choose this pair will be deleted automatically. All the elements will be deleted, because according to the problem statement, every element equal to nums of I minus 1 and I plus 1 will be deleted. So when you will choose this element, all the elements this will be deleted. Okay, but here we are focusing that we are going to choose this element. So when we choose this element, we should not have to choose this element. So what I am going to do is max of dp of I minus 2, that is the previous one. If we are not going to choose this one, so I minus 1, then I minus 2, the previous to previous, I minus 2, plus if we are choosing the current element, we will write down the, you can see, element value and its frequency, right? And what about if we don't choose this one? That is, this one is not chosen, so this one is not chosen. So if this one is not chosen, we can choose this one, right? That is the previous one, which is equal to dp of I minus 1. So this condition totally, like this equation is totally valid when this element difference is valid, like current element minus previous element. Okay, what about this element, this condition is not valid, so we will move to the else part. Else part is actually, so you can see the element is something like this one. Let's say we have the pair, let's say 5 comma some, let's say its frequency is 8, and let's say another pair is 7 comma its frequency is 9. Let's say we have these two pairs. So you can see if we are going to choose this element, still we can choose this element because the difference is greater than 1. So if we are not choosing this element, right, then still we can choose this element. So we have a new equation. You can see if you look out my code, it is actually we can choose this else part. Okay, so we are going to write down a new term over here, dp of I exactly equal to dp of I minus 1, because the difference is not 1, it is greater than 1, so we can choose the previous element also plus its element into frequency. So this is the exact equation that you are going to write. Okay, so let's head over to the code to understand this one in detail, how the things will work. Okay, so yeah, what I have done is like first I've taken a pair with an empty pair to consider one based indexing. So first I've sorted this array, and yeah, I've taken its element comma frequency in this vector pairs stored. You can see storing all the vector. You can also use a hash table to do that, but I have done via sorting, right? So take its size and start with an dp, that is going to help us. So yes, what I have done is dp of 1 will be the, you can choose the only one pair, that is s element into its frequency, and for the rest of the cases if the difference is exactly 1, so if you are going to choose the current element, then you will go for the dp of I minus 2 plus choosing the current element points that you are going to get. Otherwise, if you don't choose, then you will go with dp of I minus 1. And what about if the difference is not 1, which is greater than 1? Okay, so if the difference is greater than 1, so you will choose the previous element as well as the current element. Okay, so this will be the total points that you can get, maximum number of points, right? Each time you can see I'm trying to maximize that. And finally return dp dot back, which is the total number of points, maximum number of points you can get. So this will give you all test cases passed. So if you guys have still any doubts, you can reach out to us through the comment section of the video, and thank you for watching this video.